from our substitution and elimination work. Okay? And we're going to cover trial and improvement, is what it's called. So basically, trial and improvement means, guess and check. That's what it means. Okay? So for this first example, I want you to solve that equation. How do I do that?
It's 22.
No, it isn't. But how do I solve that equation? What do I have to do?
Subtract 3 from the 3 and the 28.
Okay, so subtract 3.
That gives you 2x equals whatever that is. X equals 25. You divide the both by 2, you divide the 2x and the 25 by 2.
I think it's 11.
And x equals
12.5. I think should be the enough.
Go
What? No, it's just she enough.
So yes, the answer is 12.5. It's a great story. So, that's how we solve an equation, right? We do opposite operations, find a value for x. But now, how do I solve that equation?
That got me on the test. I hate that.
Well, you can't solve that the way we did on the test. That's different. But, how do I solve this?
You can't.
X squared plus 3x equals 20. Well, you can.
Subtract x.
Yeah. But you can't add them together. X squared and x are two different terms.
So you just want 3x cubed.
Okay, continue.
3x cubed.
No, that would be if you were multiplying. If you're multiplying, then you add the exponents together. But here we can't. So, from what we've learned so far, we cannot solve this problem. We don't have the tools yet to do it. So, what we do is this trial and improvement, guessing and checking. So we're going to pick values for x and see that they work. So, for example, I'm going to start with x is equal to 2.
I know what this is.
I don't want to know what it is. So, I'll start with x is equal to 2. So, 2 squared plus 3 times 2 equals 28. So, let's see. If this is equal to 28, then I have the right answer. So 2 squared is 4, plus 3 times 2 is 6,
you just need to guess.
which is equal to 10. So those are not the same. So 2 is not correct. But my answer is less than 28. So I will increase my value for x again. So I get 3 squared.
Also, it's like something to do with square roots. I like it. So you just kind of like...
It's evaluating expressions, like we did before. So 3 squared is 9, plus 3 times 3 is 9. Equals, well, it doesn't equal 28, sorry.
9 plus 9 is 18.
Which does not equal 28. So 3 did not work, but my answer is getting closer. So I'll try once more. 4 squared plus 3 times 4 equals 28. Let's see what we get. So 4 squared is 16, 3 times 4 is 12, and 16 plus 12 is equal to 28. So those are equal to each other. So my answer is x is equal to 4.
I don't get this. Just guess the number.
You're just guessing a value for
Then
x.
you got it.
Yeah. You just pick a value for x. Any number you want, and then evaluate it. And what you're looking for is your answer for whatever you pick for x has to be equal to this. So I had to make it equal to 28. This one wasn't, this one wasn't, this one was. So that means our answer is 4. I just pick numbers for x and try it. So the trick with these is you have to know how to evaluate expressions. Okay, subbing into an expression, evaluating it. You know, you might have exponents, well, you will have exponents, and you just need to know how to do that. If you know how to do that, then this is not so bad. However, it gets a little more difficult. Let's take this example. So, almost the same, except now it's equal to 36. Okay? So, I've already done x equals 4 for this. Oops. Right? X is equal to 4 here, so 4 squared, 3 times 4, got 28. So I know that 4 is not going to work. So I try the next biggest number. I'll try 5. So 5 squared plus 3 times 5. Okay, so 5 squared is 25. 3 times 5 is 15. So that is equal to 40. So 5 is too big, but 4 is too small, which means my answer is going to be a decimal. So we can try 4.5. So, 4.5 squared plus 3 times 4.5. That is equal to. So 4.5 squared is 20.25 plus
No, it's not.
13.5. So that gives me 33.75. So we're getting closer, but not there yet. So we keep trying numbers. We keep trying numbers. I'm going to skip to 4.7 just to save us some time here. Okay, so 4.7 squared is 22.09 plus 3 times 4.7, which is 14.1, which is 36.19. So 4.7 is really close to what we want, right? But it's not exactly 36. Now, sometimes with these questions, you might not get exactly 36. I mean, I know a method I can work backwards and solve for x exactly, but in this case, we can't do that.
What about 4.750?
Well, that's the thing. We're not going to keep going more and more and more and more and more because sometimes the decimals might be 8 or 9 before you get an exact answer. So for what we're looking for, I would say, find a value to the nearest decimal, for example. That would be this. 4.7 would be my answer to the nearest decimal. If I said to the nearest, 2 decimal places, then you could try, 4.75, 4.76, however you want to do it. Or in this case, I guess 4.68, right? You'd work backwards. So for what we're doing, mostly it'll be 1 decimal place, which means you will need a calculator for most of this to be able to solve them. Okay, any questions so far? Yes?
I don't get that.
Any other questions so far? So where'd you get lost, David? Because rather than paying attention, you just decided, I don't know how to do this, and then you've been staring at your pen for quite some time. So,
No, I was looking at it.
okay, and what don't you get?
Well, from the beginning,
Okay, what don't you understand?
why do we have to get that?
Because you don't know how to solve for x.
And
And
Translation unity.
I don't know. What don't you get?
you're just picking values for x. You're picking whatever value you want. Any number. Okay? You pick any number, then put it in for x here. So you have x squared, so if I picked 8, it would be 8 squared plus 3 times 8. Then you just calculate it and see what you get.
Okay.
If what you get is equal to this, then your answer is correct. If what you got was bigger than this, then that means you have to pick a smaller number. So instead of 8, try 7. If it was smaller than this, then you need a bigger number. So if instead of 8, try 9. Okay?
Okay.
With me so far?
Yep.
Okay. Let's try a different looking example now. And I'm going to fix this. So this example is the same type of question, just written differently. Okay? So I still need to pick values for x that will give me 60. So where should I start? Throw out.
62.
Where should I start? Throw out a number. 5. Okay, let's start with 5. So I change x to 5, and I have to solve this. So 5 times 5 minus 2, which is 3, which is equal to 15. So 15, not quite there yet. Let's give me another example, another number, which will have to be bigger than 5. 7.
No, 6.5.
8.
7 it is. 7 times 7 minus 2, which is 7 times 5, which is 35. So we're getting there.
14 times 10. 8.5.
I'm going to, we'll leave with whole numbers until you find,
8.
so we'll start with
8.
So 8 times 8 minus 2, which is 8 times 6, which is 48. So we're getting closer.
9.
11.
No, it's not 9. It's 8 point something.
It's not.
So that's 9 times 7, which is,
8.
oops, sorry,
60.
63.
I mean, it is 8.5.
8.4. No, 8.6.
Sure. I'm going to do 8.8, only because it'll make the math easier
It's
for me.
8.5.
Can I use your calculator, please?
Yes, of course.
Oh, thank you very much.
So you have 8.8 times 6.8, which is 59.84.
Yeah, but round it up, it's 60.
Yes, if we round it to the nearest whole number, it would be 60, correct?
Okay, so it's 8 more, 8, no,
8.9.
8.85. No, 8.
8.5.
I'll try 8.9 for now. 'Cause that's what David
8.9
said
is
first.
61.
Oops, 8.9 times 6.9,
This will be
which is 61.41.
41.
So that's too big.
8 point, I
8.
don't know, 800.
Well, you said 8.5 earlier. That's why I pointed to you. So we'll try 8.85.
It has to.
Or pretty darn close. So that's 8.85 times
Yeah.
6.85, which is equal to
60.
60.6225. Now, here's what I would say. Depending on what I asked you for, if I said to the nearest decimal place, we could have stopped here. Because like you said, David, that would round up to 60, and that is very close to 60. If I said to 2 decimal
But
places,
that one was.
then I would ask you to do
That's
this.
59.
You can't get it. You have to round it up. You have to.
But that one was closer.
But you can get closer. So this is still bigger. So I would say put 8.83 or
But
8.82.
it was closer than this.
Then this one, yes.
That is closer. That's
No, this one was closer. It was 0.16 off. This one's 0.62 off. So this one's a little bit farther away.
No, it was 0.60, no? Not 0.16.
I thought I said 0.16.
0.6. You said point.
Yeah, 0.16 is
Oh, yeah.
the same thing. Okay? So that's what this entire section deals with, is picking values, putting them into your equations, and then trying to solve them. Any questions? Any other questions?
It's just guess.
Exactly. It's guessing and checking. It's exactly what it is. David, you with me?
Yeah.
Shimon? You with me? Okay. So then our work will start on page 131 in your textbook. So you can open up your book and try some of those values.